Hey there, universe nerds. Have you ever wondered what will happen to the sun when it finally runs out of fuel? Spoiler alert, it won't explode like a massive star, but it won't shine forever either. Instead, it will become a white dwarf, the quiet, glowing ember left behind when stars like ours die. White dwarfs are cosmic ghosts, reminders of stars that once burned brightly. Today, let's explore what they are, how they form, and why they're some of the strangest objects in the universe. The story begins with nuclear fusion. Stars shine by fusing hydrogen into helium in their cores. But eventually, stars like the sun run out of fuel. Without fusion to support them, they expand into red giants, shedding their outer layers into space. What remains is the hot, dense core, a white dwarf. It's about the size of Earth, but with half the sun's mass packed inside. That makes it incredibly dense. A teaspoon of white dwarf material would weigh several tons. White dwarfs don't generate energy anymore. They shine only from leftover heat, slowly cooling over billions of years. At first, they're extremely hot, glowing blue-white. Over time, they fade to red, then black, becoming what astronomers call a black dwarf. But the universe isn't old enough yet. No black dwarfs exist because white dwarfs haven't had enough time to cool that far. Every white dwarf we see today is still glowing. These stellar remnants are surprisingly common. About 97% of all stars in the Milky Way, including the Sun, will end up as white dwarfs. That means when you look at the night sky, most of the stars you see are destined for this quiet fate. Even though they're small and faint, white dwarfs may be the ultimate destiny of starlight. White dwarfs also obey strange physics. They're supported not by fusion, but by something called electron degeneracy pressure, a quantum effect that prevents electrons from being squeezed too close together. This weird rule of quantum mechanics is the only thing keeping white dwarfs from collapsing further. If they're too massive, more than about 1.4 times the sun's mass, known as the Chandrasekhar limit, they can't survive as white dwarfs. Instead, they collapse further into neutron stars or black holes. But white dwarfs can still be explosive. In binary star systems, a white dwarf can steal matter from a companion star. If it gathers too much, it can ignite in a runaway reaction, a Type A supernova. These explosions are so bright they outshine entire galaxies, and astronomers use them to measure the expansion of the universe. So even in death, white dwarfs can go out with a bang. Some white dwarfs also show surprising activity. A few have atmospheres contaminated by heavy elements, suggesting they're devouring asteroids or planets that wandered too close. Others spin rapidly or have magnetic fields thousands of times stronger than Earth's. They may be stellar corpses, but they're far from boring. Studying white dwarfs also helps us understand the age of the universe. By measuring how fast they cool, astronomers can estimate the ages of star clusters. They're like cosmic clocks, ticking away slowly as they fade. And since they're the fate of most stars, white dwarfs tell us about the long-term future of the cosmos. So what is a white dwarf? It's the quiet, glowing remnant of a star like our sun. Dense, hot, and slowly cooling, it represents the final chapter for most stars in the universe. Next time you see the sun, remember, billions of years from now, it too will become a white dwarf, shining faintly in the dark, a ghost of the star that once gave us life.